Hi everyone, welcome back to the course Essentials of Object-Oriented Design and Programming. So we are in the module 2, Methods and Polymorphism. So in this model, we were discussing the constructor, default constructor, property constructor, destructor, and polymorphism, method overloading, function overloading, and as well as the UML diagrams like the sequence and collaboration diagram in this module 2. So in this session, we'll be discussing constructor and the types of constructor in C++. So before discussing constructor, imagine that a class is named. I'll tell you what is constructor first. The constructor is a special member function used to initialize the object of the class. That is what constructor. Let us say why we need a constructor. So imagine that a class named the student containing attributes such as register number, name, department, and CGPA. Whenever an object is created, we may need these values to be initialized automatically. But if hundreds of objects are created and assigning values manually becomes a repetitive and the tedious process. And to solve this problem in C provides constructors that automatically initialize the object data members when the object is created. Okay, in simple terms, a constructor prepares an object for use immediately after its creation. So that is why we need a constructor. And coming to the definition back, so constructor is it's a special member function used to automatically used to initialize the object of the class, or whenever the object is created, it is going to be called automatically. So here the function name of the constructor is same name of the class name. Constructor doesn't have any return value and return type. And check out this syntax for constructors. No return type. Class name is a function name. It may have some parameters and open close brackets. So here we are having a definition of the constructor. Okay, let us see a simple example how the constructor is actually working. So the name of the constructor is, remember, the name of the constructor is going to be the name of the class, and it should not have any return type. Okay, check out the example. So the class name is student. In a public access mode, I define all the functions and variables. So here the data attributes are register number, name, department, CGPA, respectively int, string, and float are the data types of the attributes. And here it is a function whose name is same name of the class name, no return type, and it is not having any parameter. And this function is a constructor, a default constructor actually, used to initialize the register number, name, department, CGPA, and end of the function and end of the class. So in a main function, whenever the object is created, so this function will be called automatically, and the attributes of that object will be this one on and CSE 8.75 respectively. Okay, so here I define the constructor inside the class. So to define a constructor outside the class, very simple. So check out the same example. Student is the class name, attributes, and declaration of the member function. It's a constructor, default constructor. So to define a function outside the class, very simple. Use the scope resolution operator in between the class name and the function name. Function name is student, right? And the class name is student. So scope resolution operator says that defining the constructor outside the class. Okay. And so we are having some common rules for defining a constructor. So it should be declared in public scope. It should be automatically invoked whenever the object is created. It should not have any return type. It cannot be inherited, and constructor cannot be virtual, and we cannot refer the addresses because it belongs to only one class. Whenever the object with the constructor or destructor cannot be used as a member of a union. Okay, so these are all some rules to be followed while defining using the constructors. So let us see types of constructor. So we are having three types: default constructor, a parameterized constructor, and a topic constructor. Let's see one by one. Coming to default constructor, as soon as the object is created, the constructor is called, and it initiates the data members. That's what default constructor. So automatically will be called whenever the object is created. That's what called as default constructor. Let us see the example. So the class name is student, and member they these are all the attributes, register number, name, department, CGPA are the attributes, and function having the same name with the class name, no return type, hence it is a constructor, and no parameter. So this is what called as a default constructor, and the default constructor is initializing the register number, name, department, CGPA respectively, and end of the function and end of the class. So in a main function, I'm creating the object. So class name space and identifier. So S is the object of the student class. Whenever the object is created, the default constructor will be invoked automatically. So whenever the function is automatically called, and it for the object S, the register number, name, department, CGPA will be this, or initialized automatically. Okay. The other case, for suppose you didn't define the default constructor, so the compiler itself defining its own default constructor, right? So here the programmer, for demonstration, I have given the explicit default constructor here. If the programmer doesn't define this, the compiler will generate its own automatic default constructor. Okay. So when I call register number, name, department, CGP of the object S, that will be displaying this one Anand CSE 8.72 respectively. Right. So let's move on to the parameters constructor. In simple words, a constructor with parameters. That's what called as parameters constructor. Sometimes it is useful for initializing the initial values for the attributes of the class. That's what the use of the parameter constructor. Or it allows to the value can be passed to a class at the time of object creation. So that is what the use of the parameters constructor. Let us see the example. You'll understand easily. I'm using the same program site modification, and class name is student, and the register number, name, department, attributes. And here, instead of default constructor, I just define the constructor with parameters. So constructor is function name should be the same name of the class name, no return type. It may have the parameter. So if it is having a parameter, that's called as parameters constructor. So the parameter R, N, D are used to initialize the register number, name, department, CGPA respectively, end of the function and end of the class. Okay. So coming to the main function, I'm creating the object yes. So in the default constructor, check out the program. The default constructor, no parameter, automatic initialization. So whenever the object is created, this will be called automatically. Coming to this parameters constructor, so whenever the object is created, I have to pass the parameter to the parameters constructor. Then only the parameter constructor will be called. So while creating the object yes, with the bracket, I'm passing set of parameters respectively. 45 given to R, Anand is given to string N, and CSE will be given to string D, and 8.75 will be given to float C. For the object S, the attributes register number, name, department, CGPA are initialized with the parameters R, N, D, C. Okay. And later, if I call the S dot register number, name, department, CGPA, and this values will be displayed. For the object S using parameters constructor, the object S attributes are initialized. That is what parameters constructor. Move on to the copy constructor. So whenever I wanted to copy the attributes of one object to other object, already one object is initialized, created. So from that, I just copying all the values to the new object. Hence, we can use the copy constructor. Okay, so here ampersand is actually used. Ampersand in point is already we use, right? So ampersand is the address. So here ampersand address of the one object is actually used to copy the values of one object to the other object. So that is what the copy constructor. Let us see the example. The same program, class name is student, and attributes. This is the parameters constructor. Just now we saw, right? Parameters constructor used to initialize the register number, name, department, CGP of the object. Okay. And check out this. It's a constructor having one parameter. The parameter must be the object of the same class. What is the class name? Student. So this ampersand is actually a reference of this object is actually used to copy the values to the new object or calling object. Okay. So this object is already created. So with that object's attributes, what are the attributes? Register number, name, department of the S will be copied to the calling object register number, name, department, CGP. Okay. So void display is displaying the register number attributes, all the attributes within the class itself, and end of the class. So coming to the main function, so check out this one. S1 is the object. It's a parameters constructor. So I'm creating the object S1. I'm passing 4 parameters for the object S1. So this function with this parameters will be called for S1 object. 45 Anand CSC and 8.75 will be given to register number, name, department, and CGPA. So S1 object is created and the values are initialized by the parameters constructor. Coming to S2, this S2 object, second object is created and whose values are copied from S1. Here, what happens here is S2 equal to S1 is actually, it is in this line, it is invoking the copy constructor, right? So actually, I can read it like this: S2 in a bracket S1. So S1 object is already created, which will be passed to this S. So S1 register number, S1 name, S1 department, S1 CGPA will be copied to the calling object S2. So S2 name, register number, department is assigned with S1 name, register number, department, CGPA. So S1 object attributes are copied to S2 object attribute or initialized to S2 object attribute. So this is what the copy constructor invocation are calling. And finally, I'm calling S1 display, display. So S1 object values are displayed and S2 object values are displayed. Both are same because it's copied value from S1 to S2, right? So this S2 equal to S1 is the line where the copy constructor will be invoked. Okay. So that is what the 3 types of constructors in C++. End of the chapter 1. Thank you. Hi everyone, welcome back to the course Essentials of Object-Oriented Design and Programming. So we are in the module 2, Methods and Polymorphism. In this session, we will be discussing about static constructor in C++. In the previous session, we discussed about constructor. So what is constructor? It's a special member function used to initialize the object. So default constructor, parameterized and copy constructor all we discussed. So coming to static constructor, actually C++ doesn't have the static constructor. So static is the keyword can be used to with the member functions and data members, but not with the constructor. So the purpose of the constructor is used to initialize the contents of the object or the attributes of the class, and static method doesn't have the instance associated with them. So hence there is no such a static constructor in C++. But we will be having a static data members and static member function. Okay, so static member data is very simple. Only one copy will be there and shared among the entire class. That is what a single copy. And lifetime, the lifetime is it's a storage duration where they created before the main function and they destroyed when the program is ended. So accesses, they can be accessed the entire class using the object. And coming to static member function, the function can directly access the other static data and other static functions. So they are called using the class name and the scope resolution operator. That is what static member function, static data members. But we are not having static constructor in C++. And this program is actually trying to demonstrate how the static data member is actually used. Only one copy is there, that is retaining the value in between the function call. That is what static, right? So my class name is test. In a public access mode, I'm having a count and the name, which is an integer and string. So both are declared as a prefix static or static member data. So to initialize the static member data, it should be initialized outside the class by using scope resolution operator because the count is belong to test class. So in return type, it belongs to test class, scope resolution operator, and the member data. So it is initialized to 0. Similarly, name is given as some text. So in the main function, I can call the static member data in the same way without creating object. So class name, scope resolution, count, which is going to call the static member data. Similarly, member function, member name. Okay. So let us see the other way. The second one, static member function, static method. A class name is test in a public access mode. I'm having data type boolean. It is initialized as the boolean, which is static, either true or false. And I'm having a function called init. Init is the function. It's a static member function. If it is not initialized, so static called the constructor called the only one. So we are actually trying to mimicking the static constructor, but we are not having a static constructor. With the member function, we are mimicking the static constructor. The constructor is it is automatically called whenever the object is created, right? In the same way, we are going to mimicking the static constructor, but with the static member function. So constructor means the function name should be the same name, right? So it is not a static constructor; it is a static member data. We are mimicking the how the static constructor actually working. Okay, and the boolean is initialized to true. So that's what this function. And here I'm calling the default constructor. So here the default constructor is actually defined. So no root and type, function name is the same as the class name. Inside the default constructor, I just call the static method in it, right? So I told you, right? We are trying to mimicking the static constructor by the static member function. This is the static member function called inside the default constructor, which means whenever the object is created for the test class, automatically the default constructor will be called, which is going to invoking the static member data. Okay. So, and static member data initialized to false at the outside the class, end of the class. Outside the class means very simple. So return type is data type is bool, and the class name is test, scope resolution, and initialized is my data, and it is initialized to false. In a main function, I'm creating the object for the test class. What happens? Object 1 is created. So it is going to call the init function. Init function is going to be initializing the static constructor called the once message will be printed, and it's initialized to true. Initially it is false. After the first object, it is going to be true. Okay. And test B, again second time the object B is going to be called, and it is going to call the init function. When I'm calling init function, already it is initialized means it is false, so it is never print the message because it is already initialized to true. So never initialized means it is not initialized means it is fail because it is initialized to true for the first object A. So it will be the cout function will be never called for the second object B. Coming to third object test to C for that, because initialized is the static member data. It must be only one copy will be there shared among all the object. Okay, for this second object, initialized is true, so that this condition will be failed. So cout never printed. And coming to this one, test to see. So third object init function is called already initialized, so this cout will never be executed, right? So it will be initialized to only once, and once it is initialized, the cout never be called again and again. So we are trying mimicking the default constructor as by calling the static member function to mimicking as the static constructor. Okay. So the same example given over here, just go through. I'll share the content in the snippet. That is the end of the session. Thank you. Hi everyone, so welcome back to the course Object Essentials of Object-Oriented Design and Programming. So in this session, we'll be discussing copy constructor in C++. We'll understand what a copy constructor, why it is used, syntax, and how it works. And we'll be discussing what is copy constructor. So copy constructor is a special type of constructor that creates a new object by copying the contents of the already available or existing object. In other words, when we wanted to want one object to have the same values of another object, we can use the copy constructor. So usually we'll be using the ampersand reference operator to copy the values of one object to another object. So here ampersand x. So x is if the x is an object means ampersand x is going to use the notation used to copy the object's value from another object. So the general form of copy constructor would be the class name inside the bracket, constant and the class name ampersand object. So that ampersand object is the reference to an existing object. The class name is the name of the class when the constructor is going to be created. So the compiler will automatically provides a default constructor if you do not define the one. Okay. So why we need a copy constructor? Suppose we already created a object, an initialized with the values. Instead of assigning the each member individually to another object, a copy constructor can copy all the values in a single step. Okay. And so the benefits are we see duplication of object. Just already one object will be created. From that we can duplicate it. Improved code reusability and readability, and essential for classes containing dynamically allocated memory. Okay, so consider this example. So here the class name is student, and contains a 4 member data, register number, name, department, CGPA. So the parameters constructor initialize the values to whenever the object is created. R, N, D, C are the parameters used to initialize the register number, name, department, CGPA by whenever the object is created with the parameter. So this is the parameters constructor. Whenever the parameters constructor is called with the parameterized object, so this parameters constructor will be called, and the S1 object is initialized these two with these values. Okay, and so here we are passing parameters to the parameters constructor. So coming to this one, this line, second object is created, S2 equal to S1. This statement is automatically invokes the copy constructor, which means, so S1 object is actually given to S, right? So ampersand of S1 is the reference. So the S1 is given to S. So S1 register number, S1 name, S1 department, and S1 CGPA will be given to the calling object S2. S2 name, register number, department are copied from S1's name, register number, department, CGPA. S1 is given to S, and S1 register number name will be given to the calling object S2 name, register number, department, etc. Okay. So the values stored in S1 are copied to S2 object. As a result, S1 and S2 contains identical data. Okay. So this is how the copy constructor is actually working. By calling the display function, it displays the S1 and S2 both are identical. Okay. So this confirms the data from S1 is successfully copied to S2. Okay. So the key points to remember in the copy constructor is a copy constructor creates a new object from an existing object. So it has the syntax of this one. So constant, constructor, constant, class name of the same class, and the object reference. Okay, that's it. And we are having one more, shallow and deep copy constructor. So shallow means check out one object is already created. obj1 is already created. In a shallow copy, what happens is second object is created. So both the objects pointing to the same memory location. So that is what obj1 is the original object. obj2 is second object. So obj2 also pointing to the same location. This is called as shallow copy. So check out this example. obj1 is pointing this memory location. obj2 will be pointing this memory location. So even though both are having same values, the memory location of second object would be the different one. So this is what called as deep copy. A separate memory address will be created for the object 2, and there we are having the copies or values. Whereas in the shallow copy, both will be pointing to the same memory location. So this is not actually recommended, shallow copy. Deep copy is actually recommended. So that is what we discussed in this class, copy constructor in C++. Thank you all. Hi everyone, so welcome back to the course Essentials of Object-Oriented Design and Programming. So in this session, we'll be discussing copy constructor in C++. We'll understand what a copy constructor, why it is used, syntax, and how it works. And we'll be discussing what is copy constructor. So copy constructor is a special type of constructor that creates a new object by copying the contents of the already available or existing object. In other words, when we wanted to and want one object to have the same values of another object, we can use the copy constructor. So usually we'll be using the ampersand reference operator to copy the values of one object to another object. So here ampersand x. So x is the, if the x is an object, means ampersand x is going to use the notation used to copy the object's value from another object. So the general form of copy constructor would be the class name inside the bracket constant and the class name ampersand object. So that ampersand object is the reference to an existing object. The class name is the name of the class when the constructor is going to be created. So the compiler will automatically provide a default constructor if you do not define the one. Okay. So why we need a copy constructor? Suppose we already created a object, an initialized with the values. Instead of assigning the each member individually to another object, a copy constructor can copy all the values in a single step. Okay. And so the benefits are we see duplication of object. Just already one object will be created, from that we can duplicate it. Improved code reusability and readability, and essential for classes containing dynamically allocated memory. Okay, so consider this example. So here the class name is student, and contains a 4 member data, register number, name, department, CGPA. So the parameters constructor initialize the values to whenever the object is created. R, N, D, C are the parameters used to initialize the register number, name, department, CGPA by whenever the object is created with the parameter. So this is the parameters constructor. Whenever the parameters constructor is called with the parameterized object, so this parameters constructor will be called, and S1 object is initialized these two with these values. Okay, and so here we are passing parameters to the parameters constructor. So coming to this one, this line, second object is created, S2 equal to S1. This statement is automatically invokes the copy constructor, which means, so S1 object is actually given to S, right? So ampersand of S1 is the reference. So the S1 is given to S. So S1 register number, S1 name, S1 department, and S1 CGPA will be given to the calling object S2. S2 name, register number, department are copied from S1's name, register number, department, CGPA. S1 is given to S, and S1 register number name will be given to the calling object S2 name, register number, department, etc. Okay. So the values stored in S1 are copied to S2 object. As a result, S1 and S2 contains identical data. Okay. So this is how the copy constructor is actually working. By calling the display function, it displays the S1 and S2 both are identical. Okay. So this confirms the data from S1 is successfully copied to S2. Okay. So the key points to remember in the copy constructor is a copy constructor creates a new object from an existing object. So it has the syntax of this one. So constant, constructor constant, class name of the same class, and the object reference. Okay, that's it. And we are having one more shallow and deep copy constructor. So shallow means check out one object is already created, obj1 is already created. In a shallow copy, what happens is second object is created, so both the objects pointing to the same memory location. So that is what obj1 is the original object, obj2 is second object, so obj2 also pointing to the same location. This is called as shallow copy. So check out this example. obj1 is pointing this memory location, obj2 will be pointing this memory location. So even though both are having same values, the memory location of second object would be the different one. So this is what called as deep copy. A separate memory address will be created for the object 2, and there we are having the copies or values. Whereas in the shallow copy, both will be pointing to the same memory location. So this is not actually recommended, shallow copy. Deep copy is actually recommended. So that is what we discussed in this class, copy constructor in C++. Thank you all. Welcome back to the course Essentials of Object-Oriented Design and Programming. We are in the module 2, Methods and Polymorphism in C++. And in this session, we will be discussing about destructors in C++. In the previous session, we discussed copy constructor in C++. And now we are moving on to the destructor. So destructor is actually used to release the memory which is occupied by the constructor. Generally, constructor is used to allocate the memory to the object and initialize the values to the object, and it is occupying the memory. So the reverse is actually destructor. So it is usually to use to deallocate a memory and do the cleanup activities for the class and the object and class members whenever the object is deleted or destroyed. So destructor is called for object when the object passes out of the scope of its explicitly deleted. Our destructor is a member function which is invoked automatically whenever the object is goes out of the scope or explicitly destroyed by the delete keyword or delete function. And destructor has the same name as the class name preceded by the tilde symbol. So it is a special member function used to release the memory occupied by the constructor or object or members of the class. Okay. And here we are having some rules for the destructor. So destructor does not have any arguments. So similar to default constructor, should not have any arguments. It should not have any return value similar to constructor, even void, and it cannot be declared as a constant, volatile, or static. So no static constructor, no static destructor. However, they can be invoked by the destruction of object declared as a constant or volatile or static. So it can be declared as a virtual. Okay, so let us see the example for destructor in C++. Check out this code. Class name is capital T test, and we are having two special member function. One is default constructor, this one is destructor. So destructor is similar to the constructor, no return type, no parameter, having the same name as the class name. Only difference is tilde symbol is actually prefixed in a function. So this is the constructor will be called automatically whenever the function is whenever the object is created, and this destructor will be called automatically whenever the object goes out of the scope, or sometimes delete function is explicitly called the destructor. So whenever the scope ends, whenever the object scope ends or the program terminates, the destructor will be called automatically. Or whenever the scope of the object is over, so it will be called automatically. So end of the destructor and then end of the class. So coming to the main function, create the object T1. Whenever the object is created, the constructor will be called. So that is what the first one. And second line, I'm creating the T2, T3, T4, three more objects. So three more times the default constructor will be called. So three times, four times the constructor is going to be called. Default constructor is going to be called. And whenever the program ends, terminates, that returns 0, which makes that the scope of the object is no longer needed, which means end of the code, the objects are no longer needed, our scope of the objects are getting over. So at this line return 0, the T1, T2, T3, T4 objects are terminated and destructor will be called automatically. That is what given over here. Okay. So constructor is used to allocate the memory, destructor is used to release the memory or destroy the objects. So that is what this in this class we discussed, in the session we discussed destructors in C++. Thank you all. So hi everyone, welcome back to the course Essentials of Object-Oriented Design and Programming. So we are in the module 2, Methods and Polymorphism in C++. In this session we will be discussing constructor overloading, that is polymorphism. Let us start. So polymorphism, already in the beginning we discussed polymorphism means taking many forms. So one task can be done or implemented in different ways, or one entity can act differently in different ways depending upon the situation. So this is what example we discussed in the beginning. So a man can be taking many form like individual or an office executive or a sportsman or a business fellow or a salesperson or a customer in a grocery shop, or a family man. So like this, one entity can take many forms. That's what called as polymorphism. And moving on to the polymorphism taking many forms. So the ability of a message to be displayed in more than one form. That's what polymorphism. So we are having two types in that. One is runtime and the compile time. So runtime polymorphism, during the execution time, it is decided. That's what called as runtime polymorphism. Compile time is before the execution. During the compilation time itself, the polymorphism actually implemented or experienced. So in the compile time, we are having two categories: function overloading and the operator overloading. So these are all satisfied in the compile time. At the runtime, we are having virtual functions. We will be discussing after inheritance the virtual functions. Let us see what is function overloading in this session, or constructor overloading. Already we know what is constructor. So constructor is a special member function. It's a function having the same name of the class name. It doesn't have any return type. So it is used to initialize the objects. That's what the constructor. So here constructor overloading is using multiple constructor in the same class, and each constructor is defined differently. That is what constructor overloading. The constructor must follow the rules, as we know the constructor rules. All the constructor in the class should have the different number of parameters, then only we can say it is a overloading. So it is also allowed to class to have a constructor with the same number of parameters with the different data types too. Let us see the example, we'll understand easily. So consider this code where we are implemented constructor overloading, or else function, all types of constructor are discussed in the program, both I can say. So I'll take in this way, constructor overloading. Okay, so one constructor is implemented in different ways. That is what constructor overloading. The same example program which we discussed in the from the beginning, student class having the members register number, name, department, CGPA, all are declared in public for the safe side, because constructor should be declared in public, defined in public. Okay, so my first constructor is same name of the class name, no parameter, no return type. So it is a default constructor used to initialize the member data, register number, name, department, and CGPA. Okay, it's a common means 0. Name is empty, and the department is common CSE, and the CGPA is 0.0 initially. The dummy values. So this default constructor used to initialize this dummy value for all the objects. Okay. So coming to the second constructor, which is a parameterized constructor. So having 4 parameters: integer R, string N, string D, and float C. The respective data type is used to initialize the respective attributes of the class. So register number is integer, name is string, and the department is string, and the CGPA is float. So this parameterized constructor, so constructor with parameters, right? So it's a constructor. So having same name of the class name, no return type, having some parameter. So this is 4 parameters are there in the constructor. So it is a parameters constructor used to initialize the attributes of the class. This is one way. So default constructor, parameters constructor. You can have parameters constructor with a single parameter, 2 parameter, 3 parameter, and so on and so forth, depending upon your wish. Okay, so here I taken the parameters constructor program in this to make it simple. And coming to this constructor is actually having the object of the same class. So it is a copy constructor. So object of the same class. So this object is already created. So from this object's register number, name, department, CGPA values are copied to the calling object, a newly created object. So this object is implicit. So a newly created object, register number, name, department are initialized with the already created objects S objects, register number, name, department, and CGPA. This is the copy constructor. So one single class can have many types of constructor. So constructor is actually overloaded here. Constructor is implemented in different ways, right? That is what constructor overloading. And display function, as we saw in the previous example. So register number, name, department, CGPA displays the attribute and end of the class. In a main function, I'm creating the object 1 S1, and I'm passing these parameters. For this S1, definitely the default constructor will never be invoked because it is going to invoke the parameters constructor. I'm passing parameters, and I'm creating S2 object. For this, whenever the object is created, a normal object is created, default constructor will be called. So that's the nature. And for S2 equal to S1, so in this line, what happens here is, so here S2 equal to S1, single equal to, actually it is given a double equal to, S2 equal to S1 would be calling the copy constructor. This is a mistake. S2 equal one equal to, only one equal to should come, so it is a mistake, typo here. So S2 equal to S1, which is going to be calling the copy constructor here. So S1 object is already created. So S1 object is given to this S, and S1 values are copied to S2 objects, register number, name, department, CGPA. And when we are calling S1 and S2, both will be identical. So here the point is constructors, default constructor, parameterized, and the copy constructor. You can have as many as constructor as you want to explore the constructor overloading. So here I made a simple program by the default, parameterized, and the copy constructor as a constructor overloading example. Okay. So another example for constructor overloading, consider the class name is area. Area is a class name. One integer attribute area, lowercase area, and this area A is capital. So the function default constructor is initializing the area as 0. This is the default constructor. And second function is a default parameters constructor having only one parameter. That parameter is given to area equal to side into side. So this function, parameters function, is getting this parameter and multiplying side into side, and that will be given to this area member data. Initially 0, so this parameters constructor calculating the area of the square, actually area of the square. And third is having, this is also parameters constructor having two integer parameter. So these two integer parameters are multiplied and assigned to the area. So for each constructor, it's having its own area. For default constructor, area is 0. For this single parameters constructor, area is side into side. For two parameters constructor, area is length into width. Okay. So default, parameterized, single parameterized, and two parameterized. Two parameters are there in the parameters constructor. So this is also example of constructor overloading. And while invocation, check out this, coming to the main function, display function is displaying the area. Okay, so coming to the main function, creating the object A1. For this A1 object, area will be 0, is initialized. For A2 object, I'm passing single parameter. So this parameterized constructor will be called for the A2 object, and this area will be 5 into 5, 25. And for A3 object, I'm passing two parameters, both are integers. So 10 into 20 will be multiplied and given to area. For A1 object, area is 0. For A2 object, area is 25. For A3 object, area is 10 into 20, 200. So respective display function will be called, respective area will be displayed over here. Okay. So it's an example of constructor overloading. I think that's the end of this session. Thank you all. Hi everyone, welcome back to the course Essentials of Object-Oriented Design and Programming. We are in the module 2, Methods and Polymorphism in C++. In this session, we will be discussing about method overloading in C++ as a part of polymorphism in C++. In previous session, we discussed constructor overloading as a part of polymorphism, and now we'll be seeing method overloading. So already we discussed the types of polymorphism: runtime, compile time. Compile time examples, implementations are function overloading and operator overloading. And coming to function overloading, it is the process of having overloading the same function with a different implementation, or implementing the function with the same name with a different definition. That is what function overloading. So it requires each redefinition of function with a different function signature, maybe different types of parameter, different sequence of parameters, number of parameters in a function. So these are all defining the function overloading. So programmer does not have to remember the multiple function name. So that is the use actually. So for example, print int, print hello, or the overloaded methods. So print is a function, so it may print the integer, it may print the string actually. While calling the print function, no argument is passed, so that also will work. And second and third is passing an integer and hello, string, so both will be working. So allows one function to perform different tasks. That is what the function overloading. And matching functions called with the overloaded method. So how it is happening? For example, the case one, if the direct match is found, no confusion, simply call the appropriate function. In case two, if the match is not found, so that time linker will be generated. So however, direct match is not found at the first, the compiler will try to find out the match. Otherwise, it will try to convert the typecasting. So that also not possible. It will create a linker error. And in case 3, if an ambiguous match is found, so an arguments match more than one overload function. So we are having a 2 match found. That is what ambiguity. So that time compiler will generate an error. So this usually happens because of the all standard conversions are treated equal. And check out this example. Two function name is same, return type is different, parameters are different, definitions are different. So here common is only the function name. Function is implemented differently and having different types of parameters. Return type also different. So it is having 2 integer parameters. So here 2 float parameter. Definition is same and return type is different. Okay, so this is a simple example of the function overloading. Same function name, different parameters, different return type. We'll see another example. We'll understand easily how the function overloading is actually working. Consider this program where I'm having without classes. Actually, we're trying. We are having 3 functions. Function name is volume. Return type is integer, only one parameter, that too integer. So this is the function number 1. So this function number 1 getting single parameter, it is returning the cube of the parameter. So what are the parameter I'm getting? Side into side into side, which is going to be side cube, side power 3. And coming to second function, the function name is, wait a minute, yeah. Coming to the second function, the function name is volume, the common name. Return type is float. It is having 2 float parameters. Radius and height are the 2 float parameters. So this function calculating pi r square, pi into radius into height, pi r square h. So volume of the cylinder is actually calculated. That value is returned. So return type is float. So function name is same. Return type is different. Parameters are different. And definition also different. Second function is over. Coming to third function, return type is long integer. Long integer, function name is same, volume. It is having 3 parameters, int length, int breadth, and int height. So 3 integer parameters. So the definition is calculating length into breadth into height, LBH. So volume of the cuboid. So here the point is function name is same, rest is different. Return type different, parameters different, parameter types different, number of parameters different. So one function implemented are defined in different ways, and it is having different parameters, different types of parameters, and also return types also different. So entire things, parameters, return type, definition, all are different. Only thing is function name is same. So this is the good example of function overloading. In a main function, I'm declaring the variables, necessary variables. First one I'm calling to call the volume of cube. So I'm getting one single parameter integer, and I'm calling the volume of volume s, single parameter integer. So this function will be, the compiler will match this function because it is passing integer s. So s is the integer, so single parameter integer. So this function will be matched. So this is going to be returning some s cube. So that will be printed over here. Second one, I'm getting radius and height. Radius is float, height is float. So I'm calling the volume r comma h. So both are float. So the match is this one, this function. So volume of the cylinder will be returned as a return value that will be displayed over here. And coming to third one, and 3 parameters passed, L, B, and the height. L, length, breadth, and height, 3 parameters. So all 3 are integer. So the perfect match is the third function. So this function returning the volume of cuboid. So function name is same, implementation differs, parameters differs, return type differs. A good example of function overloading. So here this function overloading is implemented without class. Okay. And another example for function overloading. So here function declaration and function definition. Check out the function definition. Function name is sum. Here number of parameters are common, but return type is also common, but the parameters inside the parameters types are different. So here both are integers, second one both are double, and third one both are character. So function with the same name with a different definition with the different types of parameters. Definition also differs. Definition, so sum of two integer, and second one is sum of two floating point number, and third one is sum of two character. So sum will be ASCII number will be done. So return also converted to the ASCII number. And in the main function, I'm passing the respective integer parameter for the first sum. So this function will be found, and second one double x and double y will be passed. So no need to specify double x and y. So x and y are two values are passed over there, and third one character x and y will be passed. That is sum e comma f are the character, and c and d are the double, and a and b are the integers. So the respective functions are matched with the respective function calling, and it is calculating the sum of integers, sum of double, and sum of characters. So here the point is some function name is same, and parameters count of parameters same, but the type of parameter and the return type also same, type of parameter is different and definition different. So another example for function overloading without class. Okay, that's you can try this program, overload a member function so implement the same program using class. Okay, overload a member function using area, so implement the same function with the class. So you calculate the area of the rectangle, square, and the triangle. So function name should be area. So use inside as a class with the object call all the functions. Okay. So some methods cannot be overloaded. So methods that differ only in return type, so cannot be overloaded. So parameters declaration that differ only in a pointer versus array, and if the parameter differs only in the presence of absence of the constant and the volatile, and using type def does not introduce new type, since it cannot be overloaded. So methods differ only in their arguments, default arguments, that cannot be overloaded. Differ only in terms of reference parameters, and normal parameter also cannot be overloaded. Okay, so that's it about the function overloading. End of the current chapter. Thank you. Hi everyone, welcome to the course Essentials of Object Oriented Design in Programming using C++. So we are in the module 2, methods and polymorphism in C++. In last session we discussed about constructor overloading and method overloading. In this session we will be seeing about operator overloading in C++. So let us see what is operator overloading. Operator overloading means overloading the existing operators in C++. So we will be assigning an extra operation or additional functionality to the existing operators. So the way the operators work with the user-defined data types such as classes and objects, that is what operator overloading. Or we will be granting a special functions or meanings or work task to the standard operators like addition, subtraction, multiplication, division, equal to, all the operators without affecting the original meaning. We are adding some special meaning to the operators or special task to the operators. So it doesn't change the original meaning of the operator. For example, if you're overloading plus arithmetic plus operator, so the basic meaning is addition of two operands, right? So the same way, overloading plus operator is going to be addition of two objects or addition of two entities. So that is what operator overloading. So enabling the C++ operators to work with the classes and objects actually. So the overload operators are working with the objects using traditional operators with user defined objects. We are having object, obviously it is user defined. From the classes we are getting objects. So the overloaded operators is working with the object. So it need a great care when overloading and overloading it is misused. A program is difficult to understand. Okay, so let us see the syntax for overloading operator. So we have to overload, define a function for an operator. So OP is the symbol, plus, minus, minus, less than, greater than, any symbol, return type of the function, class name, scope resolution, and in which class we are overloading, and the operator keyword, and OP is the operator symbol. Inside the bracket we are having arguments. So, and after that we have to define a function. The function is defining what the operated overloaded function will do. Okay, so the function name is actually the keyword operator and this symbol, which symbol you're going to overload. This is the syntax for overloading an operator. And some operators cannot be overloaded. Being said, all the operators plus, minus, less than, greater than, all these operators can be overloaded, but we have some restriction. So the dot operator is used to access the member, object dot the method, object dot the member function, member data. Dot operator and the reference operator cannot be overloaded. And scope resolution operator, generally scope resolution operator used to define the scope of a particular member data or member function. So that operator cannot be overloaded. Size of operator. So size of operator is a built-in operator used to give the total byte of memory allocated, reserved for the particular data type. If integer means depends on compiler 2 byte or 4 byte memory. So that size of operator will not be overloaded. And the conditional operator, ternary operator. So these operators cannot be overloaded, but the precedence associativity of the operator cannot be changed. So precedence means BM does bracket, multiplication, division. So that is the operator precedence associations. These and all will not be changed. It is following as it is in the order. So no new operators can be created. So existing operators can be overloaded, and no overloading operators for built-in types. Built-in types like any operator, size of, for example, size of, it's a built-in type, it cannot be overloaded. So that is what some restrictions on operator overload, or some operators cannot be overloaded. So in operator overloading, we are having two categories. One is unary operator overloading, and the second one is binary operator overloading. Unary operator overloading means we are having one operand and one operator, which means minus a. A is an object, minus is the operator. For example, plus a. Plus is the operator and a is an operand. So the operand is actually object. And coming to binary operator, like a minus b, a plus b. So one operator and two operand, which means two object and one operator. A less than b, a greater than b. So these are all the binary operator overloading. So let us see first the unary operator overloading. So the syntax for unary operator overloading, as I said already, is return type. So scope resolution, which class it belongs to, and operator keyword, and which symbol you're going to overload, and the list of parameters, and the definition for the overloaded function. So we know return type is any valid return type for the function. Most probably return type is actually object type or class type, and OP is the operator overloading. What is the operator to be overloaded? So that operator, and operator is a keyword, so it's a must. So that is what unary operator overloading syntax. And let us see the example for unary operator overloading. The class name is number. Number is my class name. One private member, integer x. In a public, this is the constructor actually, default constructor used to initialize the member data x equal to 0. And this is the constructor, parameter constructor. So this parameter used to initialize the member data x equal to n. And this is the overloaded unary minus operator. So return type is void, nothing it is returning. So operator is a keyword. Which operator? Symbol minus symbol is actually overloaded. No parenthesis, no parameters inside the parenthesis. And this operator is actually negating the whatever the value of the member data x. So whatever the x is there, so that will be negative sign is actually applied to the operator. So here you can notice operator minus is actually negation. Actually unary operator minus a means negation. So we have to overload the operator as well as we have to align with the original meaning of the minus operator. Okay, so it is negating the value of member data x into minus x. So x is assigned with the negative value of x, and this function displaying the x value. What is the x value? So end of the function and end of the class. So semicolon used to specify the end of the class. Hash include header file and the namespace is ready to avoid the naming conflict. And coming to main function, I'm creating the object by the parameterized constructor. So n of 7. So n is the object, 7 is the integer. So this parameterized constructor will be called and 7 will be assigned to n. For the object capital N, x value will be 7. Okay. So after that, I'm calling n.display. For the n object, this function displaying x value is 7. Okay. And here I'm invoking the overloaded unary minus operator. So minus n. Generally, the functions are called with the dot operator. So this function called with the object.disp. Constructor will be called implicitly, and the overload operator will be called like this: operator and the object. So already I told you the overloaded operator working with the class object. So working with the objects actually. So minus n is actually I'm calling the overloaded minus operator by the object n. Okay, right? So it is coming to this. So whatever the value of x will be taken as minus x for the n object. After this overloaded unary minus operator overloaded function invocation, I'm just calling what is the value of x, n.display. So now x value will be negated by this statement. So x value will be minus 7. Okay. So this is the function definition, constructor definition. Operator overloaded function without affecting the original meaning of minus operator, and object created by the parameterized constructor. Calling the this function to check the what is the value of x. X will be initially 7, and I'm calling the overloaded minus operator with the object n. Okay, and after this x value will be negated, and to check that I'm calling n.display. Displaying x value will be minus 7. So this is the simple example explaining how the unary operator minus is overloaded. So like this, you can check out the book or material to or try the other unary operator overloaded simple programs. And next is binary operator overloading. In the binary operator overloading, we are having 2 operand and 1 operator, which means, for example, a plus b is the binary operator overloading. The a and b are the objects. So the overloaded functions are working with the objects. So let us see the example. So here I'm going to overload the operator plus. Operator plus is going to be overloaded. So there will be 2 objects to be added with the operator plus. Okay, so my class name is test, private data r, integer r, member data r. In a public mode, I'm having one parameterized constructor, parameters constructor. So x value will be given to r. So by default, I'm giving x as 0. Okay, so x will be given to 0, or you can have a default constructor. Both are valid only. Okay, so but here I'm using parameters constructor x as 0. Initially, it will be r will be 0. Okay, so this is the return type of this operator is actually return type is class type. So return type is class name. It means so this function will return the object type. That is what actual meaning. Operator keyword plus operator to be overloaded. So inside this, I'm having one constant object of the test flag. I'm using the address of the object. Okay, so the parameters inside the same thing is actually used in the copy constructor. So inside the constructor, we are having object of the same class. So here also object of the same class, test class, which is a constant. So whose address is actually taken as the parameter. Okay, so that is what. So local object res to store the result. So result dot r. So for this object, it is having its own private data r. So res dot r would be the r plus this objects r. So every object which is created having its own private data r. For object res, it will be having a separate r value, and for this obj, it is having its own private data member r. Okay, so I'm returning res. Res is actually object of the test class. So it is returning the test type, which is the class object type. Okay, so this is the operated checkout. It is adding two objects. I'll tell you how it is working. So print function displaying the r value. What is the r value of the respective calling object? Okay, so end of the class, end of the function, and end of the class. So test class private data member r, one parameter constructor. Initially by default value it is saying x equals 0, and later on we can change the x value. So x will be given to r, and our test operator is plus is going to be adding the two objects r value. That value is returned to the new object res dot r. Okay, so coming to the main function, let me tell you how it is working. I'm creating two objects c1 comma c2. So in both the cases, it is going to call the parameterized constructor test, which means now the x will be for this object c1, x will be 1, and 1 will be given to r. So c1 dot r would be 1. And for the c2 object, I'm passing 3, so 3 will be given to x and x will be given to r. So c2 r value will be 3. For c1 r is 3, for c2 object r is 3. Okay, and now I'm creating a third object c3. So c3's initial x value would be 0. For c3 object, initial x value would be 0. So if you're not passing any parameter, so by default it is going to take the x value from this, and it is going to be assigning to r 0. And that c3 would be the c1 plus c2. So c1 and c2 are two objects of the test class. So here plus operator is overloaded, and it is going to call the overloaded plus operator function. Okay, so in this line, the operator plus overloaded function will be called or invoked. Okay, then c2 will be given to obj, and c1 will be a implicit object. Okay, c1 will be a implicit object, and c2 is the explicit object here. So c1 and c2 will be passed over here. So we are having a local object res. So res dot r would be c1 dot r plus c2 dot r. Actual meaning c2 will be given to obj, and this would be the c1's r. So c1 r plus c2 r. So both r's are added. Two r values of two objects are added, and that will be given to res dot r. So res object will be created here. For that, the x value will be 0 and 0 will be given to r. So for res, r value is initially 0. After this statement, c1 dot r plus c2 dot r would be 3 plus 1 plus 3 is added. That will be given to res dot r. So res dot r now 4. So in for res object, r will be 4. And I'm returning the res object, and res object given to c3. What is the res value? Res dot r 3. And if I print c3 dot print, c3 will be printing r value, that will be res dot r value, that is 4. Okay, so here I'm repeating test class, member data r, parameters constructor r equal to x, overloaded operator plus function adding two objects, and the print function displaying the respective objects r value, real value actually. We're going to convert this program into real plus imaginary complex number addition. I'll tell you in next slide. So two objects are created, c1 and c2. So both are calling the parameterized object, constructor. For c1 r value will be 1, and for c2 object r value will be 3. So remember, for C1, one memory will be created separately and it is having its own R value inside that. For C2 also, one memory will be created, and in that memory object, R value will be 3. And for C3, a new memory will be created for the object, third object C3, and that will be the summation of the two objects C1 plus C2, which means it will be calling the operator plus function, passing C2 to obj, and C1 is implicit. So res.r would be c1.r plus c2.r. So this r is implicit, which is c1.r. This obj is c2.r. So 1 plus 3 is added, that will be given to res.r. So res.r will be a separate memory. That res will be assigned to C3, and C3.print will be calling the res.r or C3.r, which will be 4. Okay. And I'll be just converting this program into real and imaginary part, which means addition of two complex number by using operator overloading function. So here what I'm going to do is I'm going to add the integer r plus imaginary I. So that is what next to check out. The same coding slightly I modified. R is the integer, I is the imaginary part. So two part of a complex number, real and imaginary. So I'm just showing this is the old code, only real part is there, only one integer. So in this code, I'm having a imaginary part, real and imaginary. And the same way, instead of x, I'm having y also. So r equal to x and I equal to y. Real will be x and imaginary will be y. And same operator plus is going to be having one object explicitly and one object implicitly, and res object, res dot r, it will be r plus obj dot r, and res dot I would be I plus obj dot I. So the real part already we are having. So here I added only the imaginary part. Okay. And similarly, print will be displaying r and I. Okay. So r and I. So this pointer is nothing but the object which is calling this function is called as this pointer. So if you're not clear about that, just have the real r will be r and ri will be imaginary. So r and I of respective objects, r and I will be displayed over here. Okay. So C1 object will be 1, 2. Real will be 1, imaginary will be 2. R will be 1 and I will be 2. Similarly, for C2 object, R will be 3 and I will be 4. For respective objects C1 and C2, we are having its own R and I part, real and the imaginary part. For C3 object would be C1 plus C2. So C2 will be given to obj and C1 will be taken as implicit. So res.r would be C1.r plus C2.r. Similarly, res.i would be C1.i plus C2.i. So respective r value added and given to res.r, respective I value added and given to res.i. So I'm returning res to the C3. C3 would be now, C3 will be now taking the value from the res object. Res is the test object. So C3 dot r would be res.r, C3 dot I would be res.i. So that will be displayed in the print. Okay. So very simple. I just added the imaginary part to the old coding. So this is how the binary operator simply explain addition of two complex number by the object addition. Okay. This code is actually same style. I'll be explaining only the object. So obj1, obj2, obj3. obj1 is again the same thing. First and second part are real and imaginary. In such a we can take it. obj2 would be 3, 4, 45. obj3 would be the obj1 into obj2. So check out this function. So multiply c. So c will be obj2 and this part will be the obj1. So temp would be the multiply is the class name here. So temp dot first would be the obj1 dot first into obj2 dot first. Similarly, temp dot second would be obj1 dot second, this is implicit, into obj2 dot second. So obj2 will be taking the c and c would be obj2, and this one would be obj1's first and obj2's second. It's an implicit one. Okay. So instead of plus I used asterisk here. Multiplication operator is overloaded. Okay. So the respective parts of two numbers of the two objects are multiplied respectively, and result will be stored in temp, and temp is given to obj3. obj3.display will displaying the respective numbers, two numbers of the obj3. So that is what operator overloading, binary operator overloading. So with that, we are finishing the operator overloading in C++. Hi everyone, welcome back to the course Essentials of Object-Oriented Design and Programming. And we are in the module 2, methods and polymorphism in C++. So in last session, we discussed the operator overloading, binary operator overloading. And now we are seeing as a part of the design in and programming, we will be discussing the UML diagram. In the module 1, we discussed the use case and the class diagram. In the module 2, we will be discussing UML interaction diagram. In software engineering, designing is not only about identifying the classes and objects. We also need to understand how these objects are communicated. So here what the interaction diagram comes in the picture. So in this session, we'll be discussing interaction diagrams, types of interaction diagram, sequence and collaboration are the two types, and several examples for the components of the diagram and how to draw the diagram. Okay. And coming to the interaction diagram, interaction represent the dynamic behavior of the software system. So while the class diagram shows the structure of the system, the interaction diagram show how the objects are collaborate and exchange information in between them during the execution. So interaction diagrams helps us to, which object sends a message and which object receives the message and in which order the messages are exchanged between the objects, how does the system behave over the period of time. So thus the interaction diagram is actually providing the visual representation of the communication among the objects. And coming to the interaction diagram, we are having two categories in this, two major interaction diagram. The first one is sequence diagram and the collaboration diagram. Sequence diagram focuses the time sequence of the messages between the objects. And collaboration diagram is nothing but structural organization of the objects that sending and receiving the messages. Okay, and let us move on to the sequence diagram. In a sequence diagram, one of the most widely used UML diagram actually. The sequence diagram is it illustrates how the objects are interact with one another in a particular scenario. So the diagram is arranged vertically. The purpose of the sequence diagram is to capture the chronological order. Let us see the components of sequence diagram. First one is actor. So actor, the element represent the person who interacts with the object, person or entity who is going to interact with the object, system object. That is what actor. Or external user or device or class or object or system that interacts with the software is called as an actor. And next one is lifeline. So lifeline, the vertical line you can see over right. So that's the lifeline. The lifeline represents the existence of the objects over a period of time. Okay. So lifeline consists of a rectangular box on the top and showing the object name. So this is the class 1 is the object name, class 2 is the object name, and a vertical dashed line, and then the vertical box which is representing the lifeline. Okay, so the vertical dashed line indicates the passage of the time for that object. Each participant interacts its own lifetime. Okay, so the lifeline follows in this format: instance name and the colon class name. Instance name and the class name. So here the instance name and the class name, and this is going to be your lifeline, how long the object is exists over a time. Okay, and next is messages. So messages, nothing but communications between the objects. Messages appear generally in a sequence, and we represent messages using arrows. And lifeline and messages are the form the core sequence diagram. Check out this one. We are having a synchronous messages. Synchronous message requires a sender to wait for a response before continuing. User is a class and device is a class, and user is sending a message, open application. This is the lifeline, a vertical box, and it has to wait until the device is responded. So this is the lifeline. So where the synchronous is sending and waiting for the response, which means send request reply. Like scenario is called as synchronous messages. So this type of message is very common in the object-oriented programming. It represented using the solid line and the dashed line with the arrow overlap. Okay. Example could be a student is submitting the register number or username and password for logging in, and after verification it is giving the response. If it is correct, means logged in, otherwise error message. And next is asynchronous. So the asynchronous message does not wait for a reply. It keeps sending, it doesn't wait for a reply. So though the user is requesting or not, the devices keep sending the messages without a request. That is what asynchronous. So the sender doesn't wait for the receiver's response. So here the sender is device. It does not wait for receiver's response. It keeps sending. Okay, it is represented by solid line with the arrow. And the real world example for this one is a user places the order and receives the confirmation mail from the portal, from the e-commerce portal. Okay. And next is actually creating a message. So instantiate a new object. A create message used when a new object is created during system execution, and it is represented using the dotted arrow with the word create. Create is an angular bracket representing creating a message. For an example, in online e-commerce portal, after placing an order, for order placement, a new order class will be created. So this is the class will be created, or sorry, object will be created, not class, object. Object will be created after the message from the user. So this is what to create a message. And delete message. So once the order is delivered, everything return period is over for the same order. So once the order is received, the order object will be deleted. Once the accomplishment is completed, the order object will be deleted. Okay. So delete message used to destroy an object. That's all simple word. So once the object is no longer needed, so we can remove the object. So with the X symbol, into symbol, order is received means into symbol deletes this object. Okay. And next one would be a self message. Sometimes object sends a message to itself. This represented using the U-shaped arrow returning to the same lifeline. So this lifeline, and it indicates the internal operation or method or call. So that is what the self message. And next is reply message. Generally, we saw in synchronous message reply with the dashed dotted arrow. The interaction moves forward only when a reply message is sent by the receiver. Okay. And found messages, once the requested source found means, so we'll be getting this one. So found message originates from unknown source actually. So sender not known, shown in the diagram actually. Only the receiving object is visible. So I found this resource, that will be notified to the object lifeline. Lifeline is the object name. Okay. Last message. So it is used to messages sent. Last message is sent to an unknown destination. So the recipient is not represented within a system boundary. So the receiver is not in the scope of the system. These messages are useful when an external systems are involved in a software. Okay. So these are all the components of various components of the sequence diagram. Let us see an example sequence diagram for ATM system. So in this ATM system, some basic operations are included. Say for example, customer is inserting the card, and once the machine is inserted, it is creating a new lifeline, and it is invoking the verify card message from the server, bank server, and thereafter it is notifying the user to enter the PIN. So once the PIN is entered, so it is verified in the local self message. So if the verification is success or failure, that will be notified to the ATM machine, and hence the user is coming to know what is the status. So if it is success, the user can select the transaction, maybe money transaction or balance checking or whatever it is. Okay. So once everything is over, for every transaction, with the lifeline is keeps going on, and the particular box is representing the lifeline. And then finally, once the transaction is over, it is going to be sending back the message perform transaction function to the user. So the activation bars and lifelines and series of actions happening one after another, new object creation, new function invocation, status update, everything is represented as a one by one activity in a sequence diagram. Okay. Interaction diagram, understood diagram, that's a sequence diagram. Okay. So like this, you can try the other ATM money withdrawal just now is shown. So like this, online e-commerce portal, student enrollment, library management system, conference registration. For the various scenarios, you can draw sequence diagram. For drawing that, first you should know what all the operations happening in a particular system. For example, in online shopping, you can take a small operation. User is placing an order and going for the payment and getting the confirmation from the server. So you can take this sequence of activities happening in an online shopping system, and you can draw the class name and the lifeline and the activation bars and the functions. So there is no definition how to draw. You have to use the components and the actors and the classes, lifelines and the activation bars like this, and you can draw the messages with the messages. So these are all the messages what are invoking a function, status replay like this. First list down all the activities and you can draw your own diagram. So this is what interaction sequence diagram in the UML diagram. So with this end of the chapter. Hi everyone, welcome back to the course Essentials of Object-Oriented Design and Programming. So we are in the module 2, Methods and Polymorphism in C++. And today's session we'll be seeing about UML collaboration diagram. In previous session we studied a sequence diagram. It's a type of UML interaction diagram and how the messages are exchanged between the objects. And in this session we will learn another UML diagram, which is collaboration diagram. Okay. And what is collaboration diagram? The collaboration diagram is the UML interaction diagram that illustrates how the objects are interact to accomplish a particular task. That is what. So unlike sequence diagrams, which emphasize timing and timing of time order of the events, collaboration diagrams emphasize or focus on the relationship among the objects. Okay, so the collaboration diagram shows the objects involved in an interaction, links connecting the objects, and messages between the objects. This is what happening. So it generally software architects or designers visualize how different the objects cooperate within a software system. So that is the use of the collaboration diagram. And moving on further. So the elements of the collaboration diagrams are given here. An actor who is interacting with the system, an object used to create object for a particular class. Association is the link or connection between the objects. Message is the arrow with the message. Okay, so that is what message. Communication exchanged between the objects. So these elements describe the entire interaction diagram. So now we'll see about objects. So objects represented using rectangular boxes, and objects name colon object of the class can be specified, and you can check out this object diagram. So here object name, that is colon object class. So this is object name is nothing here, and the class name is UI. Similarly, transaction is a class name and the fine is a class name and librarian, so on and so forth. So objects participation are classified into two categories: supplier object and the client object. Okay, the supplier object is actually provides the services or methods. Supplier object is providing services or method, and client object requests services and sending the messages. It invokes methods on the supplier. For example, an user is actually user interface object may send the request to the transaction object. This user interaction object can send a request to the transaction object, and in this case UI is act as a client and the transaction act as a supplier. Okay, so understanding the supplier and the client relationship helps to identify the object responsibility. Similarly, transaction is the client and the fine is the supplier. Okay, so how the objects are interacting. So that is what this collaboration diagram represents by the supplier and the client messages objects. Okay, and coming to the link, sometimes an object can communicate with the with itself. Self link, we call that as a self link. So this occurs when an object invokes one of its own method. Such a communication represented using loop actually. uh, in this case you can check out. So it invokes on itself a loop. Okay, and the visual representation of the link is a straight line between two objects, and if an object sends a message to itself, the link carrying the message is represented as a loop icon. So this is what the loop icon. So here also the loop icon. Okay, and so here the flow is given by number. For example, enter, borrow or ID is one flow, which is having a sub flows like 1.1, that is calculate amount borrow, and 1.2 display the invalid message. So in a 1.1 we are having a subcategories like a create a object and calculate the borrow fines, and the 1.1 and 3 get borrowers checked out media, and if media is overdue, and finally the amount can borrow. So the librarian is for calculate the amount can borrow is having this many sub task. So yeah, that is happening between the UI object, transaction object, sometimes from the transaction to the fine object. So this is how the interactions between the objects are with the messages it is actually done. Okay. And coming to the messages. So messages is actually, yeah, we are having messages between the objects we saw in the previous diagram. And here in messages, we are having iterative messages and the conditional messages. Sometimes messages must be executed repeatedly. Such a messages are called as iterative messages, and we are using asterisks represent to more than once, iterative. Okay, and coming to the uh, conditional messages. So here some messages are executed only if the specific conditions are satisfied, x equal to true, or is message overdue is there or not. So these are all called conditional messages. So conditions are represented using the guard expressions. So this is what called as guard expressions. So with the square bracket, is the book overdue, is media overdue, calculate the fine, etc., etc. Okay, so you can check out this uh, convert this sequence diagram into collaboration diagram. So these are all the objects, UI, transaction, fine are the objects. So these are all the sequences happening in between, and these are all the messages or sub activities happening in the each collaboration. Okay, and this is the actual collaboration diagram between the objects, relationship between the object and messages exchanged between the objects for the library information system, that too calculating whether the borrower is able to borrow the book or what is the fine is having. That is what this a small portion of the library management system is given in this diagram. That is what we explained in the previous also. Okay, so now collaboration and the class diagram. Uh, so coming over here, this is the class diagram, and this is also class diagram. So transaction may have 0 or 1 fine. So fine may have at least one transaction. So in between the transaction and fine, so the message is calculate, borrow, fines for the given ID. It's nothing but the connection between the transaction and fine, or the link between uh, two classes, or association between the classes. That is what given over here. So the steps to create a collaboration diagram is, first I should identify the use case, and then I have to determine the participating objects in the activity, and the place the important objects near the center. And then step number 4, create the links between the object. And step number 5, I have to add messages to the link. And step number 6, assigning the sequence number. And step number 7, include the conditions, iterations if needed. So following these steps, we can create a meaningful collaboration diagram. Okay. So unlike sequence diagram, collaboration diagram do not display lifeline, but however, object creation and deletion can be still represented. So object changing state. So changing from one state to other state. Initial object creation is okay. So changing a state is actually changing from UI to the transaction, changing the state actually. So object is actually changes significantly during interaction. You can add an instance of an object and object diagram. So draw the link between them and add a message with the stereotype become. So in the angular bracket, you have to specify create the new object. So actually this transaction object is creating the fine object by the create instant, by the create message. Okay. And finally, changing the state is given. So from contract to pending to accepted. So object class name is contract and contract. So the status is actually updated. So become is the facilitated to change from pending to accepted. Okay, so collaboration diagram example. So here, this is actually a patient going to the hospital, a receptionist getting all the information and making the initial registration for appointment to meet a doctor. So that is what the collaboration diagram. So series of action, questions, change of state, and the classes are listed and they're drawn. So you can draw your own diagram. And you also try the draw the collaboration diagram for the ATM money withdrawal online shopping. Library management system is given as a part of that given in the exam explanation, and you can try ATM money withdrawal, online shopping, and etc. First, you have to list all the classes, states, activities happening. You can connect the objects with the messages, and if needed, you can check out the conditions on the normal. Okay, so with that, we are finishing the collaboration diagram, that is interaction diagram in the UML diagram. Also, end of the second module. We'll see in the third module. Thank you.